My name is Kekke. I am the CEO and Representative Director of Quantinuum K.K. I would like to thank QCware and QE Mix for this exciting Q2B 2025. And I have a short video to show you at the onset. Please watch.
The quantum computing revolution is upon us, and Quantinuum stands at the forefront of this transformative wave. As a full-stack provider, we create everything from the world's highest-performing scalable quantum computers to applications with the power to positively transform the world. From innovative hardware to cutting-edge software and algorithms, Quantinuum offers solutions across all layers of quantum computing. We're positioned to deliver useful quantum computing to our partners and customers, today and tomorrow. Our roadmap is set to deliver universal, fully fault-tolerant quantum computing before the end of the decade. Our Helios system, launching this year, will be powerful enough to encode 1 trillion times more information than our H2 system, the industry's current leader. Helios will push forward research for the development of applications in areas related to drug discovery, climate mitigation, and more. We recently unveiled our generative quantum AI framework to leverage unique quantum-generated data and enable commercial applications in areas ranging from the development of new medicines, precise predictive modeling of financial markets, and real-time optimization of global logistics and supply chains. With our systems from Helios to Sol to Apollo, coupled with the innovative capabilities of our GenQ AI framework, we're ushering in the era of practical quantum computing, moving from theory to reality.
Thank you very much. So today I would like to talk about the technological development first, and then in the second half I would like to focus more on the business as well as supply and partnerships that we have. And I would like to update you on the latest news as well. Now, Quantinuum, our company, was established as a merger of a quantum computing company in the UK and the United States. And so these two companies came together. So including those years before the merger, this is the 11th year since the establishment. We have a total of about 550 or more staffs, and more than 400 are engaged in research work. We are headquartered in Colorado of the United States, but in addition, we have offices in Minnesota and also Cambridge, Oxford, and London in the UK, as well as bases in Munich in Germany and Tokyo in Japan. So in all of these sites, we are engaged in research work. Now, last year, we announced this technical roadmap leading up to 2030. This is a development plan or roadmap. And right now we have H1 and H2 machines, and we're offering them for services, and many customers are already using these machines. And at the same time, we are developing the next generation machines and beyond as well. For this fiscal year, within this year, we're going to release Helios, which is the third generation. And it has 96 qubits, or our plan is to have 96 qubits. Now, the characteristic of our roadmap is not that we're not just focused on the hardware qubits or the error rate, but error correction implementation also has its target values. That's our characteristic. In the case of Helios, with error correction, about 50 logical qubits are to be realized within this product life cycle, and that is our target for Helios. Now, if you look at the right-hand side on this roadmap, you notice that 5th generation Apollo will start its operation in 2029, and we already have embarked on the development of Apollo. And Apollo will actually have several thousand physical qubits as the base, and we're targeting several hundred logical qubits to be implemented. Now, one of the key features of our quantum computers is the low error ratio at the time of computation. In other words, high fidelity. For commercial machines, we believe that we are at the very highest level in the world. Beyond NISQ, we want to go beyond NISQ. Therefore, at least 3 nines need to be realized. In other words, 2-qubit gate fidelity of 99.9% or 3 nines need to be stably provided for commercial use. And that is what we need to realize. Now, over 10 years ago, we started development of hardware, and we made a major decision back then. And that decision was to put quality before quantity. Suppress error rate dramatically or drastically. We put highest importance there. And then after a certain standard is realized, then only after that we try to increase the number of qubits. So that was the order of development that we have chosen. For Helios as well, we want to maintain 99.9 or higher percentage of 2-qubit gate fidelity, but at the same time, we need to double the number of qubits in the meantime as well. So that's our challenge right now. Now, at Quantinuum, we have been implementing the quantum volume challenge. You might remember this. It started about 5 years ago. And in 2020, our hardware development team put up this target. And that target, to be more specific, was in 5 years' time, every year, quantum volume is to be increased tenfold or more year on year for 5 consecutive years. And that was the target. Now, as you know, quantum volume is something that the IBM research team proposed in the early days of NISQ. And it was actually a benchmark based on the actual computation results. And Los Alamos National Laboratory in the United States, as well as others, have used this in their benchmark studies. Now, I'd like to introduce to you a hot topic or news from our company. Our research team recently has set a new record in this regard. This was announced on Monday this week. And with this new record, the quantum volume challenge that lasted for the past 5 years has come to a successful close. Now, what does this mean? What is the significance? Of course, there are different ways of looking at it, but for us, we believe that the significance of this result, the biggest significance, is that the hardware development of quantum computers has entered an engineering phase. What I mean by that is we can set a specific timeline, and based on the timeline, we can develop products and release them accordingly. We have come into that kind of a phase where that is possible. Now, for the industry, new capital is needed, and we believe that this milestone is very significant in that regard as well. Now, let me move on to talk about what kind of programs can be run using this hardware. Let me briefly talk about this topic now. Now, for computation using a quantum computer, the research subject as well as the methods have diversified over the years. And at Quantinuum, since last year, we have been addressing a new research topic, which I would like to cover now. Now, in AI research, HPC, the so-called supercomputers and high-performance AI servers and quantum computers are to be integrated efficiently. So this is one such effort. Now, in this method, quantum computer is used for generating training data, our own training data, and AI training on a conventional supercomputer can be realized or conducted. So that's the framework. Now, the research topic that we have been addressing has been referred to as GenQ AI or Generative Quantitative AI. We are conducting joint research together with the German pharmaceutical company Merck. Next, let me explain our activities in the business area. In 2022, Quantinuum concluded a strategic partnership agreement with Mitsui & Company. This partnership is very important for our activities in Japan as well as the rest of the Asian region. To be more specific, we explore future customer needs and also confirm effective use cases. So for the exploration and confirmation, we are collaborating closely with Mitsui & Company. There are conventional or computational problems that cannot be solved with current computational infrastructure, but which can be evolved relatively fast with quantum computing, which can bring value to the industry and society. We are seeking such a use case. However, that is time-consuming. Now, we work with the Quantum Innovation Office of Mitsui & Company, as well as other companies covering a wide range. We are collaborating with many parties in this area. And also, we have commercialized in the area of computational chemistry, as well as cybersecurity. We are engaged in joint marketing efforts as well. Finally, the technical seeds of Quantinuum has been a subject of collaboration with Mitsui & Company as well. Mitsui & Company is leading the product development using the technical seeds. On the right-hand side on the screen, you notice this patent that Quantinuum owns, which is called Quantum Token. Mitsui & Company is leading this world's first demonstration of this technology using NEC's QKD hardware, which was successful. And therefore, in such a fashion, strategic partnership is expanding its scope from sales activities all the way to product development.
January this year, we also closed the strategic partnership with SoftBank. One of the topics in this partnership is to validate the data center and communication infrastructure implementations toward the commercial phase of the quantum computing. Recently already, due to the advancement of AI, the requirements of the performance and so functionalities for data center is changing, and it's been more demanding ever since. And quantum computing itself requires also very special requirements, such as very special cryogenic technologies or high output lasers, which were not common in the conventional data centers. So it will be quite difficult to try to use the quantum computing in the traditional data centers. So in the future, in Japan, if we want to realize the commercial use quantum and classic hybrid environment, we have to develop the plan for the data centers. And this would require not only the preparation on the technical aspect, but also it needs to clarify the business-related issues, including the cost or risk sharing. Now, along with this, in our collaboration with SoftBank, we are working together to drill down the impact, the commercial impact that we can expect from providing the commercial quantum hybrid system to the company's users, the user companies. And one of the first initiatives here is to work together to find out the potential needs there in the quantum chemical calculation and also network optimization. Now, outside of the Japan or outside of Japan, we do have many activities. One example here is our collaboration with DARPA under DoD in Japan, in US. And there, DARPA just announced in April this year, QBI or Quantum Benchmark Initiative. This is a very large-scale evaluation program, and the utility scale of quantum computing means that the cost can be paid out. I mean, actually, by the value added, that means the calculation value added will be greater than the cost. And then that is the target that is to be evaluated, and that is to be achieved by 2033 by quantum computing. That is a just of the program, and already last month, about 20 companies have been selected as the target candidate or the candidates of the first round, and we are one of them. And also in Singapore, we are developing the quantum computing R&D environment. And last year in July, we signed MOU, and also we signed a joint lab contract with different companies in November. And also, like in the case of Singapore example, we established a joint venture, large joint venture with Lawan Capital in Qatar. And in terms of the scale, the investment will be greater or equal to $1 billion, which is 150 million yen. And also, we are working with NVIDIA. And the NVIDIA just announced in March that they will develop NVIDIA accelerated quantum computing research in Boston or near Boston. And there, our hardware will be used for the Q2B platform, which is based on their DGX quantum architecture. And actually, we have been working with NVIDIA for a more long time. Quantinuum actually supplied the NVIDIA, introduced the NVIDIA's Q2Q to the quantum computer system of ours. And also recently, we have developed jointly with NVIDIA team the use of GPU-based decoder for the next generation Helios for the purpose of the error correction. And also in our chemical calculation software in Quanto, the integration with NVIDIA's Q Quantum SDK is being progressing. And so along with that, we actually also been working with NVIDIA for the DARPA's quantum benchmark initiatives that I talked about. Now, in the past 1 year, we actually made other kinds of advancement. We have announced many collaborations with many companies and also many research institutions for wide-ranging topics. And sometimes one example will be the use of our hardware for the error correction research at Microsoft, or randomness research at JP Morgan uses our hardware. So very advanced use cases are growing day after day. We are a bit unique in the quantum computing industry in the sense that we have been working on the cybersecurity area. Using our technology, quantum origin was first approved by NIST's technology standard as the software-based random generator. And so as the random generator for PQC or post-quantum cryptography, quantum origin is now validated as the tool that is satisfied NIST standards. And so we believe that will be making contribution to the social implementation of PQC. And also the quantum token POC that we did working with Mitsui in November last year That was the world's first trial, and we believe that that will be the native application running on QKD hardware, and we will work on the commercialization of this technology. We also work with RIKEN. We actually supply the quantum computing RAME to them. And at NIDO, they have the quantum HPC integrated platform project. And for that purpose, at RIKEN's campus, we have been installing our RAME quantum computer. And with their strong support, the installation has successfully completed. And starting in February this year, the RAME has become alive. And using supercomputer Fugaku as a core portion, the RIKEN's hybrid system is attracting much attention in the global HPC community as a quantum classic or quantum HPC hybrid system. So this is my last slide. I would like to share with you our activity at Quantinuum in Japan. The operation in Japan started in January 2019, and we upgraded our activities of research and develop research in Japan. Now, hardware, software, communication, we cover all these 3 areas in our research site in Japan. And this is the only research location that we have in the whole company that has all these 3 areas. And so we would like to use this very ideal research environment for our own company, and we would like to continue investing in Japan. Along with this, of course, we would like to continuously work with the Japanese companies, Japanese shareholders, and partners. And working with them, we would like to contribute to the Japan's quantum computer community. And we actually participated in Q-Star starting this year. So we believe that we'll be able to support even more our customers or customer companies' research and commercialization. And lastly, we have been conducting a long-term internship, and also we have been conducting many workshops for researchers and students. And also last year, only 1 year, we had close to 50 people of our company visiting from Japan to Japan. And so they are working for the knowledge sharing with Japanese researchers. So that's all for me, and thank you very much for your attention. And I do hope that you will come to our exhibition booth. Thank you.